Welcome to today's episode of Speak English Club, where we delve into fascinating topics with experts from various fields. I'm John, your host, and today we have a special guest who will discuss why being a math geek and a coding wizard can be so beneficial. Please welcome Mike Thompson, a math enthusiast and software developer. Hi Mike, it's great to have you here.
Hi John. Thanks for having me. I'm excited to talk about this topic today.
So, Mike, let's dive right in. What do you think makes the combination of math skills and coding proficiency so powerful?
That's a great question, John. Math provides a strong foundation in logical thinking and problem solving, which are crucial skills in coding. When you combine mathematical knowledge with programming, you're able to create more efficient and effective solutions to complex problems. Essentially, math gives you the tools to understand and frame problems, and coding gives you the means to solve them.
That sounds like a winning combination. Can you give us an example of how math and coding work together in real-world applications?
Sure. One common example is in the field of data science. Data scientists use mathematical algorithms to analyze and interpret large data sets. Coding skills are essential for implementing these algorithms and handling the data. For instance, you might use statistical methods to identify trends and patterns, and then use programming to visualize these findings and make them actionable.
That makes a lot of sense. Data science is such a booming field right now. Are there other areas where being a math geek and a coding wizard is particularly advantageous?
Absolutely. Another great example is in cryptography, which is the practice of secure communication. Cryptography relies heavily on number theory, a branch of pure mathematics. Coding skills are needed to implement cryptographic algorithms that protect our data. So, whether you're working on securing online transactions or developing new encryption methods, a strong background in both math and coding is crucial.
It's fascinating how these fields intersect. Speaking of which, how did you get interested in both math and coding?
My interest started in high school when I took an advanced math class and a computer science course simultaneously. I realized that the logical thinking required in math helped me understand programming concepts more deeply. The thrill of solving a challenging problem, whether in math or coding, was incredibly rewarding. That synergy between the two kept me engaged and led me to pursue both subjects further in college.
That's an inspiring journey. For our listeners who might be considering a similar path, what advice would you give them?
I'd say start with the basics in both fields. For math, focus on building a strong foundation in algebra, calculus, and discrete mathematics. For coding, learn a versatile programming language like Python. As you advance, try to work on projects that combine both skills, like creating algorithms or working on data analysis projects. Also, don't be afraid to seek help from online communities and resources. The learning curve can be steep, but persistence pays off.
That's excellent advice. How do you stay current with advancements in both math and coding?
I make it a point to continuously learn. I read research papers, attend conferences, and participate in online courses. Being part of professional communities, like math clubs or coding forums, helps me stay updated and exchange ideas with peers. Keeping a curious mindset and always seeking to learn something new is key.
That's a great approach. Can you share a specific project where your math and coding skills came together in a remarkable way?
Certainly. One project that stands out is when I worked on optimizing supply chain logistics for a company. We used linear programming, which is a mathematical method, to minimize costs and improve efficiency. Coding was essential to handle the large data sets and run the optimization algorithms. The project resulted in significant cost savings and streamlined operations for the company.
That sounds impressive and impactful. Speaking of projects, what are some cutting-edge fields where this combination of skills is driving innovation?
One area that's really exciting is artificial intelligence and machine learning. These fields heavily rely on mathematical concepts such as linear algebra, calculus, and probability. Coding is used to create and train models that can make predictions, recognize patterns, and even learn from data. Autonomous vehicles, recommendation systems, and even medical diagnosis tools are all driven by this combination of math and coding.
AI and machine learning are indeed fascinating. How do you think the future job market will look for people with strong skills in both math and coding?
The job market is already showing a strong demand for individuals who can navigate both domains. Roles like data scientist, machine learning engineer, and quantitative analyst are in high demand and offer lucrative salaries. As technology continues to advance, the need for professionals who can bridge the gap between theoretical math and practical coding will only grow. It's a great time to be in this field.
That's very encouraging. For someone starting out, what resources would you recommend to build their skills in math and coding?
There are plenty of resources available. For math, websites like Khan Academy, Coursera, and edX offer excellent courses that range from basic algebra to advanced calculus. For coding, platforms like Code Academy, FreeCodeCamp, and LeetCode are fantastic. Additionally, participating in math competitions and hackathons can provide practical experience and exposure to real-world problems.
Those are great suggestions. What role do mentors or role models play in the journey of becoming proficient in math and coding?
Mentors and role models can be incredibly valuable. They provide guidance, share their experiences, and help you navigate challenges. Having someone to discuss ideas with and receive feedback from can accelerate your learning process. I was fortunate to have mentors who encouraged me to push my boundaries and explore the intersections of math and coding.
Mentorship certainly seems crucial. As we wrap up, can you share any final thoughts or inspirational words for our listeners who aspire to be math geeks and coding wizards?
Absolutely. I'd like to remind everyone that the journey might be challenging, but it's also incredibly rewarding. Embrace the process of learning and don't be afraid to make mistakes, they are part of growth. Stay curious, keep experimenting, and most importantly, enjoy the journey. The skills you develop will not only open up amazing career opportunities but also give you the tools to solve some of the world's most pressing problems.
Mike, I want to touch on a topic that often comes up in discussions about math and coding. Many people have noticed that individuals from Asian countries, like India, China, and Vietnam, often excel in these areas. Do you have any thoughts on why that might be?
Yes, that's a very interesting observation, John. There are several factors that contribute to this trend. In many Asian cultures, there is a strong emphasis on education, particularly in STEM, science, technology, engineering, and mathematics fields. This cultural emphasis often translates into rigorous academic training from a young age.
That makes sense. Can you elaborate on how this emphasis on education manifests in their learning environments?
Certainly. In countries like India, China, and Vietnam, the education system places a heavy emphasis on math and science subjects. Students often attend supplementary tutoring classes or cram schools to enhance their learning. This additional practice helps solidify their understanding and proficiency in these subjects. Moreover, the competitive academic environment motivates students to excel.
It sounds like a very disciplined approach. Are there any particular teaching methods or educational philosophies that contribute to their success?
Absolutely. Many Asian education systems employ a more traditional and rigorous approach to teaching math. This often includes a focus on foundational skills, rote learning, and repeated practice. While this method may seem intense, it ensures that students have a strong grasp of fundamental concepts. Additionally, problem solving and critical thinking are heavily emphasized, which are crucial skills in both math and coding.
That's very insightful. How about the role of family and societal expectations?
Family and societal expectations play a significant role as well. In many Asian cultures, there is a high value placed on academic success. Families often encourage their children to pursue careers in fields that are seen as prestigious and stable, such as engineering and computer science. This support and pressure can drive students to work harder and achieve more in these areas.
It's clear that a combination of cultural, educational, and familial factors contributes to this trend. How can other cultures learn from this to improve their own math and coding education?
Other cultures can certainly learn a lot from this approach. One key takeaway is the importance of a strong educational foundation. Ensuring that students have a solid grasp of basic concepts before moving on to more complex topics is crucial. Additionally, fostering a culture that values education and hard work can make a significant difference. Encouraging students to engage in supplementary learning and providing access to quality resources can also help.
That's very helpful. It's always good to see how different approaches can lead to success. Before we go, do you have any final thoughts on how we can encourage more people to pursue math and coding?
I think it's important to make math and coding accessible and fun. Showing students how these skills apply to real-world problems can spark their interest. Providing opportunities for hands-on learning, such as coding clubs or math competitions, can also be very motivating. Lastly, having diverse role models in these fields can inspire more people to pursue them.
Great points, Mike. Thank you so much for sharing your insights today. It's been a pleasure having you on the show.
Thank you, John. It's been a pleasure to be here and discuss such an important topic.
And thank you to our audience for tuning in Speak English Club. Until next time, keep exploring, keep learning, and stay curious. Goodbye.